Okay, hello everyone. My name is Greg, and I am a co-founder of Aspect and one of the authors of Rules.js. And today, I'd like to talk to you about building JavaScript and TypeScript with Rules.js. So, before we start, similar question to Tyler. Can you please raise your hand if you've written JavaScript or TypeScript code before? Yeah, quite a few of you. And could you please leave your hand up if you've done that with Bazel? That's a lot more than I expected. Well done, because historically it's been a bit difficult. The Bazel support for JavaScript came out originally in 2017 when Google open sourced rules Node.js. There was a number of repository rules there. AR and NPM were supported, rules for running and testing binaries, a rule for running JavaScript tools like produce outputs, and some rules for compiling TypeScript to JavaScript. And shortly after it was released is when my journey started with Bazel. I joined the Angular team. That's where I met my co-founder Alex, and I started to maintain rules Node.js. Now, Alex and I maintained this rule set for a couple of years, but in the end, we found that we hit a dead end with it. We made improvements and performance fixes, but we found some intractable issues with the rule set. The main one being performance issues with fetching third-party deps. We had issues with third-party dep resolution, node model resolution, for those familiar with it. And we had some issues with runtime compatibility with JavaScript and TypeScript build tools. So around 2021, Alex and I devised Rules.js, and we started writing it, and it was released 1.0 in August 2022, which is just over a year ago. And we replaced the repository rules with a new one named npm translate lock that adopts PNPM instead of yarn and npm. We wrote new binary rules for running and testing JavaScript that solved some of the compatibility issues that we had. We have a new rule called JS run binary, which is for running tools that produce outputs. And that follows the API closer to what Skylib run binary provides. And we kept TS project. We didn't bring over TS library. TS project is more canonical for running TypeScript. We didn't completely drop rules Node.js. We still depend on it for the Node.js toolchain, but other than that, Rules.js was a complete rewrite. We also wrote a number of other rules that derive from Rules.js and from its APIs. TS project, for example, is in Rules.ts, which is a derivative of Rules.js. Since this rule set was released, we've seen steady adoption. You can see that little spike in August 2022 when we released 1.0, and I think it's currently around 245 stars on GitHub. And in terms of users, I went through all of the companies that we work with on GitHub and interacted with on Bazel Slack, and counted over about 100 companies that we know of that use Rules.js. There's probably a few more that we don't know about. So if you are using it and you'd like to talk to us, then yeah, come find us after this talk or at the conference. The community support for the rule set is mainly on the JavaScript channel on Bazel Slack, which has over 1,000 members. And out of the 6,000 in Bazel general, that means that about 1 in 6 Bazel users is interested in JavaScript support for Bazel. This is the last slide before I jump into the meat of it and show you some code. This shows the Stack Overflow survey from 2023, showing that JavaScript is still the #1 language used by professional developers, and TypeScript is #5. I think JavaScript's been running for about 11 or 12 years straight. And what that tells me is that there's still lots of room for adoption for JavaScript users to get onto Bazel, and we hope that Rules.js will make it easier for them. So the first problem that we found that we wanted to fix with Rules.js was performance issues with fetching third-party deps. A quick primer on npm dependencies. Users will typically define their dependencies in package.json. They'll run a package manager, npm yarn or pnpm. That creates a lock file, and it lays out a node modules folder on disk in their clone, which will typically get ignored, not chipped into the repo, but then Node uses to find those dependencies at runtime. The way this worked in rules Node.js was there was a yarn install npm install repository rules that would depend on the package.json and the yarn lock. when those rules ran, they ran the package manager. So they would run yarn install or pnpm install. The package manager would then lay out, first it would fetch the deps from the internet. It would then lay out the node modules trees in the external repository, at which point the repository will just scan the disk, see what's there, and create the fine-grained targets that users could depend on. Now, this worked. It worked okay. The main problem with it is that it was really slow because there's no way to get fine-grained fetches. You have to fetch everything for the entire monorepo that you're in. You also have to lay out the entire node modules, and in large repositories, there can be tens of thousands of these and gigabytes of data. So with rules.js, what we did was we depended instead on the pnpm lock file. And pnpm lock file is unique. Not only does it give us the full list of the transitive closure, all the dependencies that we have in the repository, it also gives us what npm deps depend on what other deps, so we can build the graph. We know what users depend on as well from the lock file. So to accomplish this, we actually wrote our own YAML parser in Starlark. It would be nice to have in Bazel core, but it wasn't there. So we wrote one of those. And after parsing the lock file, the repository will generate a function called npm repositories that has individual npm imports so that you could fetch your deps fine-grained using the Bazel downloader in this case. When we ran benchmarks like this, it turned out as expected. In this test case, yarn and npm install rules have to install the whole node modules, no matter what you run in the repository, whereas npm translate lock would only need to fetch and install the dependencies that you're building with for the target that you're running. We also wanted to provide a upgrade path for users. So if you're depending on yarn or npm either from rules Node.js or from a legacy repo and you want to go into Bazel, but it's hard to get onto pnpm, you can actually put the yarn lock file inside the repository rule under the hood. When that executes, it will run pnpm import, which generates a pnpm lock file. At that point, that file is actually written back to the user's repository. The repository restarts, and then it parses that YAML and generates the npm import statements. To make this efficient, we did something unique here. When the pnpm import bit of that rule runs, we actually generate a manifest that contains all the inputs of the repo rule and their hashes. We write that to the user's repository. So the next time the repository runs, it knows that the lock file is up to date, and it doesn't need to run pnpm import again at that point. There's another interesting thing we did with this repository rule, and this is mainly to keep the code clean and maintainable, is we came up with a pattern for Starlark classes. So a bit unique here, but basically it's a struct with a new function. It's a constructor. You can pass parameters. It'll return another struct that contains functions with lambdas that will bind the private data. And so that allowed us to keep the code a little bit cleaner and more maintainable, especially for the complex import part of that rule. Okay, so moving on to the second bit that we solved with rules.js, issues with third-party dep resolution. Yeah, good on time. So a quick primer on Node.js, how it resolves modules. There's relative imports like foo./foo there, which will generally resolve to .foo.js. There's also named imports. And if you see this named import called bar, what Node.js will do is it'll look for bar in a node modules folder that's next to the source file. If it doesn't find it there, it'll look in the parent, and then the parent and the parent. So it'll keep looking for it until it finds it. What rules Node.js did originally is it patched the require function. So monkey patched it, put in a custom implementation. The custom implementation would be aware of all of the named imports in your graph. It would know where they are in the external repository, and it would simply return the entry point to that named import. That works for many cases, but it was fundamentally incompatible with a lot of tools that don't use the require function, and it's incompatible with import statements because you can't monkey patch them in the same way. So the next approach we tried with the ruled Node.js originally was runtime linking. If a Node.js binary depended on a npm dependency, before we hit the entry point of that binary, we'd actually create the node modules folder and symlink that to a location that it could find it. That made the problem better for a lot of tools, but it had a lot of corner cases, and it wasn't Bazel idiomatic. Had trouble with gen rules in general. You can just pass a Node.js binary to a gen rule. It just wouldn't work. So with rules.js, we fixed this problem in a principled way. What we did is we just made node modules outputs in the graph. So when you run the repository rule, it generates an npm link all packages function. Inside that function are individual link packages. Linking is when you put the package in node modules. And then you simply depend on the packages you want to in the data of your binary or your build rule. And this supports lazy fetching, so it only fetches the packages you depend on and only links the ones you depend on as well. So the final problem I want to talk about is compatibility issues with JavaScript and TypeScript tools. This is primarily caused in the old rule set by separate source and output trees that Node.js tools were not aware of. I think the easiest way to illustrate why this is a problem is there's two TypeScript files here, one foo.ts and one bar.ts, where bar depends on foo. And there's two TS project rules to compile that TypeScript to JavaScript. When the first TS project executes, its input is foo.ts, and it outputs, as you'd expect, a foo.js and a foo.d.ts, which is the typings for foo. And that goes in the output tree. And when the second TS project executes, it depends on the typings of foo, but bar.ts is still in the source tree. So when the type checker looks at it, it's this TypeScript in this case, it wants to find a relative import called foo beside bar, but it can't find it because it's in the output tree. So the problem here is that you can make this work. We made it work for TypeScript because you can tell TypeScript to look in different places, but you have to make your tools aware of these separate trees, which Node tools generally are not. So the solution here was simple, a bit unusual perhaps, but what rules.js rules do by default is they copy the source files that are inputs into the output tree, and then when the action runs, you're actually depending on the output version of that source file. And so when you do it that way, when you finally get down to type checking bar, the typings for foo are beside bar.ts, and the type checker is happy. And that is the end. That's all the time I have for today. I could talk for a lot longer about rules.js. Thank you very much. And please check out our talks. We have a few talks. My co-founder, Alex, has a talk on Aspect Workflows, which is our CI/CD product. Alex and I are hosting a JavaScript Birds of a Feather session tomorrow as well. So if you have more questions about rules.js, we'll be there. And on day 2, Alex has a talk about being an imposter. He also has a Birds of a Feather session for Bazel rules offers. My coworker Derek has a talk on Bazel lib, which is one of our rules that we maintain. And coworker Matt, who's in the audience, has a talk on rules.py, which is our Python rule set. Thank you.
We have some time for questions, so are there any?
I'm interested in the copying to generate trees. In other rule sets, I've seen people like build symlink routes separately, like a clean directory and put stuff in. Can you talk about the differences there?
One of the problems with Node is it'll follow the symlinks by default, and so it'll actually leave the symlink tree. And unrelated to copying, I made another rule called JS run dev server, which actually copies the run files into another folder, which is a temporary directory just so they can be watched, because Node is not very happy with watch mode when it's looking at symlinks. But in general, there's just a lot of corner cases with that. We find it a lot simpler as a default to just copy the files. The rule set allows you to opt out if you want to do something else, but that's the default that we went with.
More questions? All right, if not, then let's thank Greg again.